Guten Tag, I'm Chris Clark from Lancaster University, here in virtual Hawaii, and I'm going to present our work on Outline Pursuits, gaze-assisted selection of occluded objects in virtual reality. Occlusion in 3D environments increases selection ambiguity as input accuracy when pointing is limited by users' motor skills. A mitigation strategy is for users to change their position to improve the view they have of an intended target. However, this is a limited option when the range of movements is restricted, for example when seated, or if the tracking space is limited. In this work, we propose to support selection of occluded objects with outline pursuits. From a user's perspective, selecting an object using outline pursuits involves two stages. The first is candidate selection, which is used to reveal potential targets using coarse-grained pointing, and to generate a distinct motion around each of the outlines. The second stage is selecting one target from the candidates using smooth pursuit-based selection, whereby users disambiguate the selection by following the motion around their intended target with their eyes. We demonstrate outline pursuits with the implementation of two concrete techniques, one for hands-free selection and one where it extends controller-based raycasting. Each leverages a different coarse-grained and selection confirmation mechanism. Two applications highlight the strengths of outline pursuits. In a virtual cityscape application, outlines not only show which buildings are interactive, but also are used in the selection process. In contrast to other gaze-based techniques, outline pursuits allows users to gaze at an object for an indefinite period without making a selection. A room planner application showcases how users are able to select an object with little hand movement and thus plan their hand placement for the following object manipulation. Separating disambiguation and confirmation stages allows the user to check additional details prior to confirming selection. We designed and conducted a user study to investigate the performance of the proposed outline pursuits techniques and gather user feedback against baseline techniques. The highlight of our results was that controller-based outline pursuits showed significantly fewer errors under high occlusion compared to the baseline techniques, and required less movement. More importantly, this does not increase with distance, supporting precise selection at a distance where alternative techniques deteriorate due to hand shakiness or calibration error. Outline pursuits does not require line of sight and requires minimal body movements for selection, making it ideal in situations with restricted movements. By adding to the already existing utility of outlines, objects can be selected without changing their properties. Dankeschön.